Hey, this is Power Overload Dev Lucius, and welcome back to a new series about me and my co-developer's journey through game development. Our game is called Power Overload and pits a bunch of small PC players against a giant boss VR player. We're hoping to add tons of abilities and guns to the game, and we're making some great progress, so stay tuned for more. Anyways, today I wanted to make some improvements, but I didn't want to be too productive, and I realized we have this HUD system in the bottom left corner that displays the character running or wall climbing, doing whatever really. There's a bit of a problem though. You can't tell which way you're facing, whether in third person or in this little HUD thing. So to remedy this, I want to add googly eyes. Why googly eyes, you might ask? Well, there's a couple reasons. 1, they're funny. 2, I want to. And 3, they shouldn't take very long. Well, famous last words. With that out of the way, let's get back to what matters, the googly eyes. So what do we want our googly eyes to do? Well, here are some basic ideas for how googly eyes should act. 1. The eyes rest when not in motion. 2. The eyes jiggle around when accelerating. And 3. The eyes don't leave their bounds. I tried a couple different methods and I ended up with pretty good results, but first let's go through all the failed attempts. Attempt 1. Force based on distance. Because both of the important aspects of googly eyes are circles, it becomes very easy to tell when the pupil has left the eye. We can flatten the disc into a line, input the radii of each circle, and calculate how far away from the center of the pupil it can be before it's touching the edge. This was a graph that I had originally implemented into the googly eye script. It would take the distance of the pupil from the center of the eye and apply a force based on that. This, however, didn't end up looking very good and was quite buggy when resting or at high speeds. Plus, the pupil didn't accelerate with the eye, which defeated the whole purpose of the googly eyes. Attempt 2 was accurate bounce physics and acceleration. So I started to remedy these issues starting with acceleration. To determine how the googly eyes should move when their container is under force is actually fairly simple thanks to this guy. Basically, we know the position of the googly eye container every frame, and we have to extrapolate the acceleration of it using math. First, let's talk about delta time. Delta time is a built-in Unity function that tells us how much time has passed in seconds between frames. This is equation 1. This equation makes sense if you think about it. What's velocity? Well, it's distance over time. Distance is simply change in position, and that can be calculated by subtracting the current position from the previous position. That's how we end up with the current position minus previous position, all divided by time, which we will replace with time.delta time. To keep track of the old position, I'll create a vector variable that updates after the calculations each frame. Next up is acceleration. And hey, this looks familiar. Yep. Just like velocity is a measure of change in distance over time, acceleration is just a measure of change in velocity over time. This is how we get meters per second when talking about velocity and meters per second to measure acceleration. Putting this all into code looks like this. We simply execute the equations and then update the previous variables. Then all we have to do is apply the acceleration to the pupil using the last equation. Putting all this into code, we can see that it works pretty well, but the wall bounces are messing up our nice clean result by adding weird velocities. Think about light hitting a mirror. When the ray hits the mirror, it reflects off perfectly. We can do exactly the same thing, but instead of rays of light, it'll be the velocity of our pupil. The equation for bounces like that look like this. Implementing this all into the program, we can see that there's some extremely realistic bouncing physics going on. I've also added gravity with a single line of code. All it does is constantly accelerate the pupil downward, which is exactly what gravity is, a constant acceleration. And with that, we have some nice googly eyes added to our character Bean. This has been Power Overload Dev Lucius. Thanks for watching.